looking at is analyzing graphs of quadratic functions. So this has a new form. So this is derived from the ax squared plus bx plus c equals 0. We know that's the quadratic equation. So first we're going to talk about that. We're going to talk about the vertex form, and then we'll talk about how to get there from the quadratic equation. So let me tell you what the quadratic functions in the form of the vertex form, what the equation is. So I want everybody to write this down. Y equals, open parentheses, x minus h, close parentheses, squared plus k. I know it doesn't look exactly like the quadratic equation, but let me explain to you what all these pieces mean, because this is really important. So we can look at this equation and we can kind of analyze what our graph's going to look like. This formula is called the vertex form, V-E-R-T-E-X form. And if you remember, the vertex in your parabola is the minimum or maximum. So it's basically where your parabola goes down, turns a corner and goes back up, or it goes up, turns the corner and comes back down. Okay, so let's talk about each of these pieces. So we have y equals, we know the y. So open parentheses, x minus h. So the x in this is the x is its axis of symmetry. Axis of symmetry. So if you remember, the axis of symmetry is where on the x-axis you can put a line through your parabola and you can fold it in half and it matches on each side. It's basically how to split it right down the middle. Okay. So, and then you have k. And k is basically the vertical movement of your parabola. So if you have a parabola, it tells you, the k tells you where your vertex is, like where it makes that corner vertically. So if it's a positive number, if the k is positive, it'll be above the x, the vertex will be above the x-axis. If it's a negative number, it tells you that your parabola, the vertex is below the x-axis. So that is the k.
Ms. Lowell?
Yes.
Okay, I think did you say in the formula that it was x minus h, or is it x minus k?
So we have open, x minus h, as in hotel.
Okay.
Close, squared, plus k.
Oh, plus k, as in a.
K as in kite.
Okay, I got you, okay.
Okay. All right. And so the h and the k, this is interesting. So the h and the k are the same thing because the h is your left and right movement of your parabola. So your h is the vertex. Your h tells you where it moves left and right. So a parabola is not necessarily, the vertex is not necessarily on your on 0. It doesn't necessarily just go through the y axis. It can be moved around left and right. So the h and the k are the same thing. Okay, so now I want to look at example 2. So let's just go through this. I know this is a lot of information. Let's look at page 324. We're going to look at example 2 before we look at example 1. Okay, so let me know when everybody's on page 324. Okay, so example 2. So we want to write our quadratic equation equation in the vertex form. So if we have an equation that is y equals x squared plus 8x minus 5. How do we get it into the vertex form? And we know y equals open x minus h closed squared plus k. So this is kind of like where we use that completing the square. So the first way to look at this is to write this in parentheses form. So the first thing I want you to do is to rewrite this as y equals open paren x squared plus 8x close minus 5. So looking at this x squared plus 8x, we can think of that as the first part. That's like our x minus h. Where does the completing the square come into play? Well, if we have parentheses around the x squared plus 8x, we want to complete the square with that, so we can come up with our open x minus h closed squared. So looking at x squared plus 8x, how do we complete the square for that? Well, we don't have a c term on x squared plus 8x, so let's put one there. And so what would that be? So we take half of the b term and then square it. So in this instance, we have 8x as our b term. So half of that would be 4, and 4 is 16. Right, so we would write this as y equals open paren x squared plus 8x plus 16 close paren. But if we're adding this plus 16, it changes our equation. So outside the parentheses, we have a minus 5. So from that minus 5, we subtract 16, and it doesn't really change it, but it allows us to do the complete the square. So again, let me read it to you what we have. Y equals open x squared plus 8x plus 16 close parentheses minus 5 minus 16. Does everybody understand how that balances out? Okay, we have a plus 16 and a minus 16. So now let's combine our like terms. So what we end up with is y equals open x squared plus 8x plus 16 close minus 21. So now, what do you guys think? What would we do next if we want to get it into?
Add the 21 to both sides?
Not to both sides. So think about the original formula. So if the vertex form is y equals open x minus h closed squared plus k. So looking at this x squared plus 8x plus 16, could we factor this out and get it into open x minus something closed squared? Since we completed the square, can we do that? So we made it a perfect square. What would it look like when we factor out the stuff in the parentheses?
It becomes 8 x plus 8.
Not 8. So you look at that.
2.
Not 8. Divide that 8 by the 2. So remember, basically, it's when you have your b term, that's going to be what your x plus your factorization is. X plus 4, right? Okay, so you have x plus 4 squared. We all agree that's the factorization of x squared plus 8x plus 16.
Yeah.
Okay, So now we have y equals open x plus 4 closed squared minus 21. Okay, now look at the vertex form. It's y equals open x minus h closed squared plus k. Okay, so we're almost there into the form, but the one difference is that it's x minus h, and right here we have x plus 4 or plus h. So we need to make that into a minus to get our actual h value. So we would write this as y equals open x minus open paren minus 4 close paren close the big parentheses squared, and then it's plus k, and we have a minus k, so which is the same thing as plus a negative 21. So let's look at this. I'll read the whole thing again. Y equals open x minus a minus 4 close squared plus a negative 21. And now that matches our y equals open x minus h close squared plus k. So from this, we're able in this equation to determine what all the pieces are. We can determine what our x is, we can determine what our h is, and we can determine what our k is. So let's go through this. So what is our h value? Nina, can you tell me what our h value is?
-4.
Yes, -4. Brian, can you tell me what our k value is?
Positive 21.
Not positive. Remember, it was a negative. It was negative. It was plus a negative 21. We had minus 21.
Negative 21.
Correct. Correct. So from this, we can determine where our vertex is. Because if you remember, the vertex, the location of the vertex is located at the point h, comma, k. So what is the vertex of this parabola? So h, comma, k. And we said our h is -4 and our k is -21. So we could say, we could plot the vertex at -4, comma, -21. That's where the vertex is. So this is where the parabola goes down and takes its turn, right at -4, -21. All right, and we also know that the axis of symmetry, which is the h, h is equal to k, is at -4. All right. Okay, and since we know a is a positive number, there's two things we know from this. We know this is going to be an opening upward graph, which is a minimum, with a vertex located at -4, -21. Okay, I'm going to stop right there, and I'm going to open up for questions. What do you guys think?
What?
Do you have any questions about this? Is this, do I need to kind of do it in a different way, or is this making sense?
So did you change the +4 to the negative to -h?
Yeah, Yes, comes in positive -21. Oh, that's the case. Sorry, the h, yeah, because the equation is actually x minus h. So we had full x plus, so it's minus a minus to make that a minus your h. Okay, let's see here. All right. Okay, so now I want to go back, now to kind of see how we got there. Let's go look and see this actually graphed. So go back to page 322 and look at example 1.
Yeah,
Okay, what page is it on?
it's on 322C.
322C. Great. Okay, so now we need to analyze the graph. Y equals, open paren, x plus 2 closed squared plus 1. And then draw its graph. Well, this is all done for us, so we're just going to look at it. So the first thing we need to do is look at this. We have y equals open x plus 2, and the formula is x minus h. So we need to make that into a minus something. So we'd rewrite this as y equals open x minus, open parentheses, minus 2, because minus a minus is a plus. But then we need to recognize that our h is actually a negative 2 and not a positive 2. Close parentheses squared plus 1. Our plus 1 is in a good shape because our k is a plus 1. Good. So then we determine our h and k values. H equals negative 2, and our k equals 1. So from there, we can find the vertex of our parabola. We'll know if it's positive or negative, or a minimum or a maximum graph. And we'll be able to look at the vertex and the axis of symmetry. So our first step, let's look at this. Our first step is to look at our graph. Okay. The graph has the same shape as the graph of y equals x squared. So let's talk about what a graph of y equals x squared looks like. This is a graph, and there's a graphic in the textbook, but they have 3 or 4 on top of each other, so I don't want to look at it. I'm just going to explain it. So a graph of y equals x squared would be a graph that has its axis of symmetry on the y-axis, or on the origin. So it's an upward opening graph with its vertex on like 0, 0. It's just an upward opening graph that falls on the origin. Okay. If you have a graph that looks like that, so you have this great graph, upward opening, let's plot. The first thing we want to do is plot the vertex. We know the vertex is open HK. So can somebody tell me where the vertex is? What is our H value and our K? I want you guys to, I need to hear you, Nina, and I need to hear you, Brian. I need to hear talking. HK. What is our H value?
-2.
Okay, what's our K value?
1.
Right. Okay, so what is our vertex? If our vertex is open parentheses H, comma, K, close parentheses, where does our vertex fall? Somebody tell me the ordered pair.
-2, 1.
Yes, -2, 1. So what you do is on your graph, you go left 2, up 1. So the graphic in the textbook will show that. So everybody look at that. Go 2 left, up 1. There's your vertex. All right. So then our step 2 is draw the axis of symmetry. So the axis of symmetry is that vertical line that goes through our vertex. So where does our axis of symmetry fall? That's our H. It's just the H part, so it's at -2. So on the graph, you'll see in your textbook, you'll see this dotted line at -2, 1. So if you're in your hand up and down, you'll see this dotted line going up and down. So that's the axis of symmetry. All right. Okay. So the next one, step 3, find and plot 2 points on one side of the axis of symmetry, such as -1, 2, and 0, 5. How do you get that? How would you know that that's how to find a point like that? This is a plug and chug. You throw a number in, right? You throw a number into your equation. So if you put in 1 for your x, you're going to come up with your y value. So if we put in 1, actually let's put in -1 for our x, because we're at -2, 1. Let's go 1 to the right and see if it's on our graph. So we have y equals open x plus 2 closed squared plus 1. Let's stick this -1 into our x. So we have y equals open -1 plus 2 closed squared plus 1. What do we get for our y value? Somebody solve it and let me know. Then we end up with an ordered pair of -1 comma something. Take a moment and figure that guy out. Okay, so if we have, let me go over that again. If we have a point at -1, 2, and we've determined that it is 1 point to the right of the axis of symmetry, we can plot the mirror image point on the left side of the axis of symmetry, because those points are just going to match up. It's just going to be on the other side of the axis of symmetry. So from our vertex, located at -2, 1, instead of going to the right 1 and up 1, from the axis of symmetry, we go left 1 and up 1. So then you get a point at -3, 2. So let me know when you guys can see that on your axis of symmetry, on your graph.
Well, I found it, but how did you get that again?
So it's basically like looking at, on a mirror. So you have whatever is on the left side of the parabola is going to match the right and vice versa. Because this is a parabola that just is going to go down and go back up. The sides are going to be the same. So we know this is an upward opening parabola. And with the axis of symmetry, the points on either side of the axis of symmetry are going to be the same distance. So basically like absolute value from the axis of symmetry. So the point we found, -1, 2, is 1 unit up from the vertex and 1 unit to the right. So the matching point on the other side of the axis of symmetry on the left side of our parabola will be the same vertical movement, so the up 1 point and left 1. So it's basically a mirror image of the point. So the one we found was -1, 2. So the one on the left side of our parabola is going to have the same y point. Its x movement is going to be different. And to be 1 point to the left of the axis of symmetry will make the x value be -3. So now let's try another one. Let's throw in a 0. Throw in a 0 to the equation and see what happens. So we have a point. We have our graph at y equals open x plus 2 closed squared plus 1. What do you get when you throw in 0 for your y? For your x, sorry. Throw in 0 for your x and then tell me what your y value is. This should just take you just a few seconds to throw in your 0. I want everybody to do that. So you have open parentheses, 0 comma something. Put that in for the original equation. It should just take you a moment to solve, just like we did for the other point.
Is it 5?
Yes, it is. Because you get 0 plus 2 is 2 squared, 4 plus 1 is 5. So now you have this point located at 0, 5. So find that on your graph. So you go from the origin, you just go up 5 and you have a point. So now you need to find how much movement it is from the axis of symmetry, 0, 5. So from that point 0, 5, head left until you hit the axis of symmetry. So that's 2 units because our axis of symmetry is located at -2. So from 0 you go left 2 units, you hit the axis of symmetry. So to find the next point on the left side of our parabola, you just need to move 2 more units to the left. You go 1, 2, and find where that lands, and that's another point. That's at -4, 5. So we've actually found 5 points without making a table. The vertex we have found by going through the vertex form. Then we threw in an x point, found that one, graphed it, figured out how many points to the right on the x-axis, on the x value it is from the axis of symmetry, and on the same y value, just move those points over, plotted your points, and then threw in another number. So we were able to draw our parabola and know exactly where it falls. So let's talk about one more thing. Not all graphs are going to be located on the x-axis. So how do we know? There's something called a translation. So translation, if you remember, is the same shape, just moved to a different part of your graph. That k value, the k value tells you where above or below the x-axis your vertex is going to be. So look at this one. We have x plus 2 squared plus 1. So we have a plus 1 right here. And we found our vertex is -2, 1. So that 1 tells us that our vertex, the y value, is going to be 1 unit above the x-axis. So you look at that k value in the vertex form, and that'll tell you where your vertex is going to fall as far as your y value. So if you have a graph like y equals open x minus 3 closed squared, and you have a 0 k value, there's no k there. It means it's going to fall on the x-axis. If you have a negative k value, it's going to fall below the x-axis. So that's just a good thing to look at. You kind of can do a check to know where that falls. Okay, so let's pause for a second. All right, so we're going to look now at page 323. Let's just look at the concept summary. We're going to skip the first half of the page. It's just confusing. So we're just going to look at these graphs, and then we'll just talk about them. So let me know when you found the concept summary, quadratic functions in vertex form. And then whoever finds it, let me know what page it's on. So
it's on, I found it, it's on B323.
B323. All right, fantastic. Okay. So the vertex form of the quadratic function is, like we said, y equals and then have an a open parentheses x minus h closed squared plus k. The reason the a is there is, sometimes you can have more than a 1 as your a value and then you pull it out. But right now we're just going to look at this, and we'll get to the a value other than 1. We'll get to that later. So h and k. This is the first part. It says vertex and axis of symmetry. So what you have is a graph. And you just have an upward opening graph. And the vertex is a point, and this one's below the x-axis. That's located at hk. So we know that. Axis of symmetry. In our form, the x equals the h. That's our line of symmetry. The x and the h are same thing. That's what we're looking at, the h and the k. So remember, in the k. Now let's talk about what the k is. So this graphic shows 3 different parabolas on the graph. Everybody see that? 1, 2, 3. Should be your second graphic. First thing we're going to look at is I want you guys to find the middle parabola. So at the origin, there is a parabola upward opening right there. So that one has a k value of 0 because it's right on the x-axis. Okay, so now on from the origin, go down until you find the parabola below the x-axis. Okay, so this one would have a k value of less than 0. So if this is anything with a minus k, like -2, -3, in your equation of x minus h squared plus k. This would mean our plus k is actually a negative number. Okay, from the origin now go up, and you'll see a parabola above the x-axis. So this will be a positive k value. This is k greater than 0. So your 3 options. Negative k is below the x-axis. No k value or 0 is on the x-axis, and a positive k will make your vertex of your parabola above the x-axis. Okay, the third one is talking about our h value, and where your parabolas fall in the graph. Starting at the origin, I want you to move left until you get, so there should be to the left, a vertex kind of on the left. We want to find the parabola that is the furthest to the left one. Let me know if you found that. It's kind of overlapping. You guys found that one? Brian?
Yep.
Nina? So if you move to the left, there's a parabola right on the origin, and then so if you're moving left, go as far as you can over, and there's a line on the left. You might even just want to lay your hand flat on the page and move it over until you find the last line of the parabola as far as left.
Oh, yeah. Okay.
Okay. Yeah, so follow that one. Just kind of draw, just follow that parabola, and that's called a horizontal translation. So that's whenever your h value is less than 0, your parabola will move into quadrant 2. It'll kind of go to the negative. That moves it to the left. If your h equals 0, so right at the origin, you'll see a parabola, the vertex just kind of goes on the origin. That's if your h value is 0. You get a parabola that just has no movement left or right. It's just on the origin. If it's not translated vertical, but we're not talking about that part right now. So now move to the right. You'll see a third parabola that is vertex hits the x-axis to the right of the y-axis. That's when your h value is greater than 0. So that moves your parabola to the right. So less than 0 moves your parabola to the left. 0 is no movement horizontally. And a greater than 0, h, or positive 1, moves your parabola to the right. Okay, and the last one is our a value. And we know that your a value determines if your parabola opens up or if it opens down. So if your a is greater than 0, you have an upward opening parabola. If it's less than 0, you have one that is a downward opening parabola. Okay, and the last one is interesting. So this one has 3 upward opening parabolas, and I'm just going to explain it. You can look at it or not look at it on the graph. So basically, it talks about the width of the parabola. You can have a skinny one, you can have a wider one, you can have a really wide one. So it's like looking at the difference between a bowl versus a cup versus a skinny vase for your shape. If your a value equals 1, it's the middle graph. It's kind of like a medium size. It'd be like I would say a cup that's kind of wide, like a bowl, like a cereal bowl. It's kind of medium of the road. It's not like a big fruit bowl, which is really wide and flat. If your a value is less than 1, you're going to have a really wide parabola. So that's going to be like a fruit bowl or a serving dish, something really wide. And if your a value is greater than 1, then you're going to have a narrow parabola, kind of a real steeper slope. So these different parts basically just tells us all the information we need to know about what your parabola is going to look like and where it's going to fall. So this equation, this concept summary, is really important. It's really important to kind of understand that. And I want to stop here for today. And I don't want to go any further forward. Okay, so we're just going to work on some of the problems on page 326. So on page 326, we're going to be doing 15 through 26 even. I don't expect you to finish them all in class. So 16 through 26 even. 15 is not a even number. So there's 1, 2, 3, 4, 5, 6 problems. And so those are going to start now, and then they'll be due in class tomorrow.